Hi again. Here I'm going to show you that how we can simulate the single server queuing system in Excel. Okay, so uh, here, as I said, in for simulation of discrete event systems in Excel, we need to track each customer explicitly, right? So we will go customer by customer, and we'll obtain the performance measures for each customer. Okay, so for customer number one, let's say at first we need to generate a random number, right? So we do this by the rand function in Excel. Okay, and after having the random number, we can obtain the service time and inter-arrival time of each customer. Okay, let's say here we have the service time. The service time, as you remember for this example, the service time was based on a normal distribution with the mean of 4 minutes and the variance of 3 minutes. Okay, so since it's normal, so we can have here norm.inv, so normal.inverse, and three parameters. B4 here is the jointed random number. 4 is the mean of the normal distribution, and square root of 3, because here we need to consider the standard deviation, not the variance. Okay, so by having this function, we obtain the service time for customer I, here for customer 1. Okay, and here we assume that the arrival time of the first customer is at time 0. Okay, so the interval time for customer 1 will be 0, but for customer 2, for example, we obtain the interval time by having the relation for the exponential distribution. As you remember, it was minus ln 1 minus r, the random number, which here is b5 for customer number 2, and divided by lambda. As you remember, the mean time of interval times was 5 minutes, and as we know that the mean in exponential distribution is 1 over lambda. Okay, so 1 over lambda equals 5, then lambda becomes 0.2. Okay, so this is how we obtain the random variable for inter-arrival time of each customer. Okay, and the arrival time of each customer will be the arrival time of the previous customer plus its inter-arrival time, right? For the first one, it will be 0. For the second one, it will be E4, the arrival time of the first customer, plus D5, the inter-arrival time of this customer. Okay, and the service beginning time, again, for customer 1 will be 0. For customer 2, as you see here, we have the maximum between G4 and E5 for customer number 2. So what's G4? G4 here, as you see here, is the service completion time for customer 1, right? And E5 is the arrival time of customer 2. So the maximum between the service completion time of previous customer and the arrival time of this customer will obtain the service beginning time for this customer, right? So SSI for customer number 2 will be here this. And the service completion time, we have the service beginning time, right? F5, right? Plus C5 is the service time, right? So yeah, start service beginning time plus the service time will obtain the service completion time. For waiting time, here we can consider the service beginning time and the arrival time. Okay, so F5 minus E5 for customer number 2 will obtain the waiting time. So what's F5? F5 is service beginning time minus E5 arrival time. So if there's any gap between arrival time and service beginning time, that will be the waiting time. Okay, and the server idle time here for customer number 2 is F5 minus G4. Again, G4 is the service completion time for the previous customer, customer number 1, and F5 is the arrival time of, F5 is the service beginning time of this customer, customer number 2. Again, if there is any gap between these two, that will be the server idle time. And the sojourn time for each customer will be the total time that each customer spends in the system, and that will be C5, the service time, plus H5, the waiting time, right? So, and by repeating these calculations for 25 customers, here we are simulating the system for 25 customers, okay? And then we can calculate the performance measures. As you see here, we have the performance measures here. The number of customers is 25, average arrival time is 4.33, average service time is 3.7, average waiting time here is 3.64, and number of customers who wait, here we can count H4 to up to H28. If they are positive, then that will be the number of customers who wait, which is 18 here. So 18 out of 25 customers wait in the line. And the probability to wait will be the number of customers who wait divided by the total number of customers. 18 divided by 25 here will be 0.72. And the average sojourn time can be calculated here as well. Server idle time, percent of times that the server is idle, and server utilization rate can be calculated as well. So here, as you see, we have the performance measure for the system. Again, if we refresh the numbers, anytime that we see a different result, as here the average time changed to 2.44 from 3.67, it became 2.44. Again, as you see, since we have just simulation for 25 customers, so because of the uncertainty, the results cannot be robust, right? And in order to mitigate with the impact of uncertainty, we need to have replications. Here we call this as experiments. So in the third sheet here, we have replicated that simulation of 25 customers for 500 times. So we have 500 replications. And as you see here, the average of waiting time in the line in this experiment is 3.37, and that's robust. If you refresh the numbers, the change in this number will be little, not that much. Yeah, so yeah, here by having 500 applications, actually we are decreasing the impact of uncertainty, so we can rely on this result. If you are interested on having the queue length, I mean the number of customers in the line, so you can calculate the number of customers in the line as here, and also you can actually have the graph of the number of customers in the line queue length. Okay, so if you go through the sheet, you will actually find out that how we can do this. Okay, so yeah, this is how we simulate a discrete event simulation, like this simple example, single server queuing model, by tracking each customers and one by one. Okay, so, and that's it. Okay, thank you.